Alright guys, so we're trying to do the worksheet for mixtures, solutions, and solvents. Formative worksheet, you already have it on Google Drive. So let's read the first question. This question is about ways to separate and purify substances. Match each term on the left with each correct description on the right. Okay, so we just have these terms which we're kind of familiar with so far, and I guess their descriptions or what they're used for. Let's read the first one. A solid appears as the solution cools. Well, I think I have a strong idea what this is, but let's read more. Used to separate a mixture of two liquids. Strong idea what this is as well. Solvent is removed as a gas. A solvent is removed as a gas. See, when I was reading this earlier, I was completely confused, but right now when I read it again, it makes kind of sense. The solvent is removed as a gas, so the solvent is the gas removed. So either evaporation or could be distillation, but it's removed as in you don't care about it anymore. I'm gonna bet more towards evaporation. And let's see, yeah, evaporation and distillation are both present. This method allows you to recycle a solvent. Okay, let's just solve this and eliminate our choices. Let's start matching it. A solid appears as a solution cools. Number one has to be crystallization, which is D. So I'll just cross this out. We're done with this, right? Okay. Separate mixture of two liquids. That has to be fractional distillation. Okay? That's kind of gone. All right. The solvent is removed as a gas. I'm gonna say it's evaporation. Could be something else. I haven't properly solved the question yet. I'm just gonna put a star on. Could be something else. Who knows? This method allows you to recycle a solvent. Recycle a solvent. I don't know what that means. Let's move on. A gas changes to a liquid on cooling. That's not a filtration or separation technique. That's just condensation, which is B. So that's gone. And the last one is separates an insoluble substance from a liquid. Insoluble filtration, that's straightforward. That's C. That's gone. So the method allows you to recycle a solvent. I think they're talking about distillation, or reuse would have been a better word, because the solvent is pure now, and I think that's what they meant. So distillation. So yeah, it's kind of where is it? The recycle word is throwing me off. I don't like that word used here, but oh well. Can't really judge them. All right, and evaporation. Yeah, that's pretty straightforward as well. So I'll remove my asterisks from here. Okay, done. All right. Let's move on to question number 2. This apparatus can be used to obtain pure water from a salt water. Sounds a lot like distillation. And I think this is a poor man's distillation setup. Let's see how well this works. What is the purpose of of the ice cold water? Okay, what is the purpose of this ice cold water? You want to make sure all that water vapor cools down and doesn't evaporate out. Well, that's what the purpose is. So you want to cool the water vapor so you can collect it. The glass arm must reach far down into the second test tube. Why? And you can pause and think about it, but I think most of you will arrive at the right answer, where it's underwater because you want to allow, you're not cooling it here, you're cooling it here. So the longer, deeper it is in the water, the more chance it has to cool, the more cooling you're doing to it. So that's the answer. To allow all the water vapor to cool down. And if it's just barely there or not even touching it, that water vapor isn't going to cool down in time and it's just going to fly off. So to properly collect it, it needs to be underwater. Okay. Where in the apparatus does this take place? Evaporation takes place in the test tube or in the boiling tube where the heat is. I guess here, sorry, this would be not too specific. This area is evaporation taking place. Condensation, I guess if you want to pinpoint it, this is where condensation is taking place, in the pipe or straw right under the water level. What is the separation method called? Well, distillation. It's practically distillation. What will remain in the first test tube at the end of the experiment? Well, it's salt water. Water is going to go out. Well, salt will be left behind. Straightforward question. Let's move on. Yeah, all right. Question number 3, page 18. Seawater can be purified using this apparatus, a distillation setup. What is the maximum temperature recorded on the thermometer during this distillation? Well, what is it? I'm going to say it's going to be very close to 100 degrees Celsius, because water is evaporating, boiling. The maximum it can go up to is 100 degrees, at which point it'll boil and not just evaporate. Now, why do I say 100 degrees? If you're confused, let me ask you to recall your heat curve for water, which will look something like this, kind of like that. And over here, this is the place where it's turning into a gas. Notice how it's constant. Remember why it's constant? When it's changing state, it stays constant. So as long as this is a gas, the maximum temperature this gas can have is 100 degrees Celsius, and then it'll escape and cool down. So the maximum is going to be is 100 degrees Celsius. Okay. How does this compare to the boiling point of seawater? Well, what's the boiling point of seawater? Well, very close to 100, that's for sure. But it's impure water. Seawater has salt added to it, right? And other stuff, but salt mainly. So it's going to be higher, because impure substances will have their boiling points be higher and melting points be lower, right? So it's going to be higher. I write like a third grader. Man. All right. On which piece of apparatus does the evaporation take place? Well, it's asking for the name, so I'll tell you. It's called the round bottom flask. Which is the condenser, A, B, or C? Well, it's C. Right? It's, how do I use a highlighter? Make it smaller. C is the condenser. Where does the supply of cold water enter? From the bottom. Right? Now why from the bottom is a good question. Why don't you guys think about it and pause the video, right? I'll be that guy. Okay, it enters from the bottom is because if you allow it enter from the top, what's going to happen is it's not going to fill the entire thing as neatly. It's just going to spill right out, right? So that'll mean it might not even touch this pipe on the inside. It might just flow here and that. So what you could do is start using a lot of cold water. And this setup is probably going to last for probably half an hour to an hour. So a lot of cold water, you're pushing through it and whatever. So it's very effective. But if you make the water enter here, it'll slowly fill up, rise all the way, then start pouring out. Then you can use a smaller water supply, right? Slower as well, with lesser flow rate, and it'll fill up the entire thing, and it'll stay in contact, more effectively cooling the entire system. Okay, that's pretty much the answer. Distillation is used rather than filtration to purify seawater for drinking. Why? Because salt is soluble and passes through the filter. It doesn't get filtered out. Well, yeah, because salt is soluble. Okay. Some of these questions are like, what? Well, let's move on. Gypsum is an insoluble in water. I think gypsum is added to cement and stuff. But cement is kind of soluble in water. I don't know. It's used in building. Like I think I hear like gypsum is something similar to marble. Not sure though. You are asked to purify a sample of gypsum that is contaminated with a soluble salt. So you can imagine it is gypsum. How do you spell gypsum? Gypsum with, let's say, something like table salt. Oops, gotta turn that off. Table salt. I said I want to turn that off. Why is it still on? Table salt. ठीक है, one is soluble, one isn't. And we did a very similar question in class. So what we'll do is, if we have a beaker, we'll add water to it. It's a weird beaker. And we'll add water to it, so I'll have a solution containing H2O plus gypsum, G for gypsum I guess, and salt, which is NaCl. Then I'll filter it. Let me try drawing a filter real quick. Right? I'll filter it. Kinda. It's really tough drawing on the iPad because the glass is very slippery. Okay, and when I filter it, all the gypsum will be left behind. Let me put that here. All the gypsum will be left behind, and all the water and what do you call it? And all the H2O and table salt will be. It didn't name what salt I'm using. I'm just using an example to showcase this. Okay. Now once this is done, I'm gonna take this, put it in a evaporating dish, kind of like that, and heat it until only salt is left. So I'll have my gypsum in this filter paper, and I'll leave this to dry, so I'll have pure gypsum, powdered form, whatever this is, and salt over here. So what instruments will I be using for this? Let's see. Bunsen burner. Well, eventually I have to heat it, right? Let me just write down heat. Heat. I'll have to heat it. Okay. So Bunsen burner, check. Distillation flask, oh, nah, probably not. Thermometer, don't really need one. Stirring rod, maybe, don't really need one again. Filter funnel, yep. Conical flask, I could use it, don't really need it. Maybe I could do all of this in a conical flask. I don't really need a condenser. I'm gonna come back to conical flask. Filter paper, yes. Tripod, don't really need a tripod. Why would I use? Maybe a tripod to heat it. Yeah, I think to heat it, a tripod could be useful. Pipette, no. A gauze, not really. And a beaker. So I have a beaker, so I don't want to use a conical flask. I do need my evaporating dish, but that's not mentioned. But step-by-step instructions for the procedure, I'll let you guys handle that. I think that's fine. All right, let's move on to the next question. Argon, oxygen, nitrogen are obtained from air by fractional distillation, liquid air at -2. Oh, I was wrong. I said -40. It goes up to -250 Celsius. Wow. Is warmed up and gases are collected one by one. Is liquid air a mixture or a pure substance? Well, I think we all know it's a mixture. And at this point, this distillation wouldn't really work if it was a pure substance, right? So it's a mixture, like argon, oxygen, nitrogen, they're all mixtures. Anyway, explain why fractional distillation is used rather than simple distillation. Well, to avoid, like to ensure when you're collecting, let's say, nitrogen is the first one, to ensure that nitrogen comes out without any impurities involved, like oxygen evaporating at the temperature nitrogen is boiling, right? So you add a fractionating column, same reason why you have fractionating column in the first place for any case, right? To ensure other gases don't evaporate and add to the impurity of the sample being collected, right? And the fractionating column, what it does is it allows it to condense back down to a cooler temperature so it can fall back down and not come out of and not be collected while you're collecting some other gas, right? During distillation, nitrogen gas is obtained first, then argon and oxygen. What can you say about the boiling points? Because you start at -250 degrees Celsius and you allow it to warm up. So nitrogen is obtained first, then argon, then oxygen. So what I can say about their their boiling point is that nitrogen has the lowest boiling point because it's collected first. You're slowly warming it. Nitrogen's the first one that comes out, then followed by argon, which is probably has a boiling point between nitrogen and oxygen. So, and then oxygen. So if I had to rank their melting points, this is what I'd do. So the melting point for nitrogen is lower than that of argon, which is lower than that of oxygen. ठीक है? All right, we're done with the question. I think question 6 is straightforward, so we'll skip that. Let's see what other questions we have. Other questions are related to chromatography. We won't be doing chromatography for the test, so I won't discuss them right now, not to confuse anyone. Okay, so I hope this helps. If you need anything else, let me know. All right, bye-bye.